Okay. Good morning, everyone. So this is Princess, instructor for C programming, and we will continue our class. And we will cover for today's class. We will cover the half of the module 2, which discuss the data types, their operations, the basic flow control, and we will take the module 2 quiz and test for the session, and also start the module 3 that discuss the flow control, module types, and computer logic. So I'm going to share my screen. Right. So as we continue on the previous lesson, we will start here the prefix and postfix operators and their priorities. So take a look at these two simple examples here in the snippet. As you can see, int I and j. So we have declared two integers here, that is I and j, and I is equals to 1 and j is equals to I plus plus, or I increment. First, the variable I is set to 1. In the second statement, we will see the following steps. Okay, the first one is the value of I will be taken, as we use the post incrementation. And the second one is the variable I will be increased by 1. Okay, in effect, j will receive the value of 1 and I the value of 2. So things go a bit different here. Okay, let's take a look. So the difference between the first snippet and the second snippet is it is on the postfix, and the second one is the prefix of the increment. So the variable I is assigned with the value of 1. Next, the I variable is incremented and is equal to 2. Next, the increased value is assigned to the j variable. In effect, both I and j will be equal to 2. Okay, so look carefully at this program. Let's trace its execution step by step. Okay, as you can see in the snippet, we declare two variables, and that is I and j. In the first statement, we include that I is 4, j is 2 times I increment, and I is equals to 2 times decrement j. The I variable is assigned to value of 4, yes, as it was written in the snippet. Number 2 statement, we take the original value of I, which is 4. Okay, so the original value of I here is 4, and multiply by 2. So here, assign the result 8, which is I times 4, 4 times 2, to j, this is j, and eventually post increment the I variable. It equals to 5 now. Why it becomes 5? Because I, which is equals to 4, then increment plus 1, so that would be 5. And then for number 3, we the pre-decrement the value of j, it is now equals to 7, and this reduced value is taken and multiplied by 2, and the result 14 in assigned to the variable I. Okay, so why j is now equals to 7 now? Since we have number letter I here, this is the variable, and we get the number 7 because of the pre-decrement, right? Since j is equals to 8 and minus decrement minus 1, so it is now equals to 7, right? So, and multiply by 2, 7 times 2 is equals to 14. So I is now equivalent to 14. Okay. What else do you need to know about the new operators? Firstly, their priority is quite high, higher than uh, multiplication and division and modulus operators. Secondly, their binding depends on whether you use a prefix and postfix version. Prefix version operators have a right to left binding. Okay, take note of that. Right to left binding, while the postfix operators bind from left to right. Okay, did you see the difference between prefix version operators and the postfix operators? The prefix version is have the right to left binding, while postfix is binds from left to right. So the priority table now reads as follows. Here is the unary, binary, and binary. So this table is not completed yet. We will see in the next slides what is the what would be the uh, priority table, priority table is. Okay, let's move to the next slide. So that would talk about short operators. So what is short operators? It's time for the next set of assignment operators that make a developer's life easier. Those described earlier deal with addition and subtraction of one. Very often, we need something other than addition or subtraction, or we want to use a value other than one. Consider the expression below. Okay, so as you can see, here is equivalent to I times 2. So in order to, so as we talk about shortcut operators are going to have the simpler form for this equation. So we can use when calculating a series of powers of 2. Here's another example. We would use this expression. Alright, so ship counter is equal to ship counter plus 10. In the language C, there's a shortened way to write this operation. Okay, so for this equation, for this statement, we can write it like this one: I times equals 2. It is it has the same meaning. I equals I times 2 or I times equals 2 is the same. And just like ship equals counter, uh, ship, ship counter equals ship counter plus 10, we can simplify that into this one. Ship counter plus equals 10. So let's try to represent a general description for such operations. If op is a two-argument operator and the operator is used to following context, then this expression can be simplified as follows. Right. So here, variable, variable is equals to variable, then operation, then what would be the expression? So we can simplify that just like variable, which is I, and then operation, like this one, and this is assignment operator, which is equal, and that expression or the volume. That would be the syntax for the shortcut operator. Instead of this one, variable is equals to variable operators, then expression, we can write it like variable operators, then equals, or the assignment operator, then expression. All right, so as you can see here in the table, we have a shortcut operator samples. Instead of writing this one, we can write it like this one. Instead of writing this one, we can write it like variable divided by equals 2. Or if it comes with modulus, we can have RAM modulus equals 10. And then if we are having a long a statement, we can just like say it like j minus equals I plus var plus rem. Right, so next let's have the next slide. Okay, so this is the character type or the char type. So far, we've treated the C language and the computer itself as a tool for performing calculations on numbers. This is consistent with the common belief that a computer is just a smarter calculator. But you know this is not true, as a computer can be easily used for word processing too. So we can define a word as a strings of characters. We can have letters, numbers, punctuation marks, and etc. We dealt with these strings during the first lesson when we used the puts function to write some text in the computer screen. Now, however, we were going to ignore strings consisting of multiple characters and focus our attention on a single character. The problem with the processing strings through, though, will come back to haunt us when we start working on arrays, because in the C language, all strings are treated as arrays. To store and manipulate characters, the C language provides a special type of data. This type of this type is called a char, or stands for character, which is an abbreviation of the word character. Right, so let's try to declare a variable for storing a single character. Okay, so here is the declaration for character, which is a char. This is a reserved keyword, and we have the variable character. So look familiar, doesn't it? Now, let's say a few words about how computers store characters. So here we have Axico. So computers store characters as numbers. Every character used by a computer corresponds to a unique number and vice versa. This system of assignments includes more characters than you would probably expect. Many of them are invisible to humans but essential to computers. Some of these characters are called white spaces. Take note of that. While other while other are named control characters because their purpose is to control the input and output devices. An example of a white space that is completely invisible to the naked eye is a special code or a pair of codes, and this is different. Operating system may treat this issue differently, which are used to mark the ends of the line inside text files. People don't see this sign or these signs, but they can see the effect where where the lines are broken. So we can create virtually any number of assignments, but a world in which each computer type uses different character encoding would be extremely inconvenient. This has created a need to introduce a universal and widely accepted standard implemented by almost all computers and operating systems all over the world. AXI, which is short for American Standard Code for Information Interchange, is the most widely used system in the world, and it is safe to assume that nearly all modern devices like computers, printers, mobile phones, tablets, and etc. use this code. The code provides space for 256 different characters, but we're only interested in the first 128. If you want to see how the code is constructed, look at the table on the right. Look at it carefully. There are some interesting facts about it that you might notice. Well, show you one. Do you see that the code of the most common character is the space? Yeah, it's 32. So here we have the space 32 here. So if the character is space, then the equivalent for decimal for that is 32. Alright, so now look at what the code of the lowercase letter a is. Lowercase, where's the lowercase a here? So decimal equivalent for that is 97, right? And now let's find the uppercase a. Uppercase a would be the decimal of 65. What's the difference between the code of a? Lowercase a and uppercase a. It's a 32. Yes, that's the code of a space. We'll use the interesting feature of ASCII code soon. Also note that the letters are arranged in the same orders as in Latin alphabet. So here, let's go to the char type values. How do we use the values of the char type in C language? We can do it in two ways, which are not entirely equivalent. The first way allows us to specify the character itself, but enclosed in single quotes. Here, single quotes, apostrophes. Let's assume that we want the variable we declared a few slides earlier to be assigned the value of the uppercase letter A. We do this as follows. So character is equals to a single quote. Then inside of the single quote would be A. You're not allowed to omit apostrophes under any circumstances. Now let's assign an asterisk to our variable. We do this as follows, right? So if you are going to assign punctuation marks or any marks or even a number, but it is a char type, then always remember to put apostrophes or single quotes. So here, the second method consists of assigning a non-negative integer value that is code of the said characters. This means that the assignment below will put an a into a character variable. So if the character variable, if the character expression or the character um, value would be integer, you don't need to put apostrophe or single quote. But if it is punctuation mark or a Latin alphabet, you need to put single quotes. But if it is integer, then you can write it without the single quotes. The second solution, however, is less recommended, and if you can avoid it, you should. Why? Firstly, because it is illegible. Without knowing ASCII code, it's impossible to guess what the 65 really means. Perhaps this is a code for a character, but it can also happen that a sociopathic programmer uses this devious way to save a number of sheep that have been already counted. The second reason is more exotic, but still true. There's a significant number of computers in the world which use codes other than ASCII. For example, many of the IBM mainframes use a code commonly called EBCDIC, or stands for Extended Binary Coded Decimal Interchange Code, which is very different from ASCII and is based on radical different concepts. So here's the difference between EBCDIC and ASCII code. For its this uppercase T. So in ASCII code, we um, we have a different character assigned to that. Alright, so let's go to the next slide. So ASCII versus EBCDIC. Now, imagine that you've written a wonderful program and decided to compile and run it on the computer utilizing the EBCDIC code. If you wrote something like this, character is equals to single quote instead of a single quote would be question mark. The compiler running on the computer would notice the question mark and use the appropriate ABCDIC code for that character. But if you wrote it like this, 63, and would it give the compiler a chance to guess what your intention was? We can assure you, even without having the EBC, the IC code table at hand. That 63 certainly does not represent the question mark in the EBCDIC code. Yes, because as we figure out earlier that EBCDIC and AXI code are different. It has different character assigned to them. So let's have literal. Now is probably a good time to bring a new term into the mix. A literal. The literal is a symbol which uniquely identify its value. Some prefer to use a different definition. The literal means itself. Choose definition that you consider to be clearer and look at the following simple examples. So here, the first one is character. This is not a literal, it's probably a variable name. When you look at it, you cannot guess what value is currently assigned to that variable. So let's have A or single quote then uppercase A. This is our literal. When you look at it, you can immediately guess its its value. You even know that it's a literal of the chart type. Let's have 100. This is a literal 2 of the int type. Okay, let's have 100.0. This is another literal, and this time it is a floating point type. And how about I plus 100? This is a combination of a variable and the literal joined together with a plus operator. This structure is called expression. All right, so please remember that if we have the combination of a variable and literal, it will be called as expression. Okay, let's have character literals. If you are inquisitive person, you probably want to ask a question. If a literal of type char is given as the character enclosed in apostrophes, how do we code the apostrophe itself? So the C language uses a special convention which also extends to other characters, not only to apostrophes. Let's start with the apostrophe anyway. The correct format looks as follows. So this would be the format. So apostrophe, then slash, backslash, then apostrophe. So let's define this character. The backslash character acts as an escape character because by using the backslash you can escape from the normal meaning of a character that follows the slash. In this example, we escape from the usual rule of apostrophe, delimiting the literal of type char. So here you can also use the escape character to escape the escape character. Yes, it does sound weird. The example below should make it clear. This is how we put a backslash in the variable of type char. So what do you think is the output if we put this statement? Character is equals to single quote, then backslash, then single quote inside. So probably the answer for this is only a single. The output for that would be a single apostrophe. Right? How about this one? The character. So since we said, as we said earlier, that the backslash, the escape character. So we escape the usual row of the apostrophe, and here, so the result for this one would be backslash. Okay, so let's have escape characters. So the C language allows us to escape in other circumstances too. Let's start with those that denote literals representing white spaces. So here we have backslash n. This denotes a transition to a new line and is sometimes called as LF or line feed, as a printers react to the character by pulling out the paper by one line of the text. So if you want to write your code, your new code, or the second statement into the another to the second line, we will use this escape characters, which is backslash n. So let's have a backslash r. Denotes the return to the beginning of the line is sometimes called as CR, or stands for car- carriage return. Carriage was a synonym of a print head in the typewriter era. Printers respond to this character as if they are told to restart printing from the left margin of already printed line. So let's have backslash a, as in alarm, is a relic of the past when teletypes were often used to communicate with computers. Do you know what a teletype is? Are you old enough to remember them? Okay, sending this character to a teletype turns into a ringer, hence the character is officially called bell, as in bell. Interestingly, if you try to send a character to the string, you'll hear a sound. It won't be a real ringing, but rather than a short beep. The power of transition works even in the IT world. Right, so let's have backslash zero. Note the character after the backslash is a zero, not the letter O. Code null, from the Latin word nullus, or none, is a character that does not represent any character. Despite first impression, it could be very useful, as we will show you in the lessons to come. So we learn the escape characters, the four escape characters: backslash n, backslash r, backslash a, and backslash zero. Okay, so now we will try to escape in a slightly different direction. The first example explains the variant backslash is followed by 2 or 3 octal digits. So the digits from the range of 0 to 7, a number coded in this manner, will be treated as an ASCII value. It may look like this. So character, then single quote, then backslash 47. So 047 octal is equivalent to 39 decimal. Look at the ASCII code of the table and you'll find that this is the ASCII code of an apostrophe. So this is equivalent to the notation. Um, Notation, a single quote, and backslash apostrophe, but only for the computers in implementing ASCII code. Okay, so it will also depend if your computer is implementing ASCII code or different code, just like ABCDIC. So here, if we are going to put apostrophe, then backslash, then the number, the computer will find the equivalent of the 47 if it is what character do it do represents it, just like this one. In this manner, in this case, the 47 represents apostrophe. Okay, so let's have the second escape refers to the situation when a backslash is followed by the letter X. Lowercase or uppercase, it doesn't matter. In this case, there must be either one of the two hexadecimal digits, which will be treated as ASCII code. Here's an example. So here we will have character is equals to apostrophe uh, backslash then x27. So here x is equivalent to hexadecimal. Then we will uh, find what is the equivalent of 27 in decimal, which is 39. Okay, so let's have char values are int values. So there's an assumption in the C language that may seem surprisingly at the first glance. The char type is treated as a special kind of int type. This means that you can always assign a char value to an int variable. You can always assign an int value to a char variable, but if the value exceeds 255 in this character code in AXI, you must expect a loss of value. So, and the value of the char type can be subject to the same operators as the data of type int. So here we can check this using the simple example. We said earlier that in AXI, the distance between upper and lower case letter is 32, and the 32 is the code of the space character. Look at this snippet. So here we have char, which is the date. This is a reserved keyword character char, and this is the variable for character. The variable name, and the variable name is equivalent to a, uh, uppercase A, and if char plus equals to 32, then char minus equals, then it will be the space. So uh, minus equals, and then apostrophe, then space. This sequence of subsequent addition and subtraction will bring the char value to the original value of a. You should be you should be able to explain why, right? So now let's look at the assignment below. They are all correct. Try to interpret their meanings. This should be a good exercise for you. So here let's have char is equals to a plus 32, and a plus a space, and 65 plus space 97 minus space lowercase a minus 32, and lowercase a minus space. What do you think is the answer? Alright, so for, as we said earlier, that the equivalent of space is 32, right? So if we have uppercase plus 32, we will probably get in lowercase here. So let's have a is equals plus space. So since 32 and space are the same, so we will get the same number. Okay, so let's have 65 plus space here. Since 65 in the AXI code is equivalent to the uppercase A, so and 32 or space plus 32, so we will also have the same answer here. Okay, so let's have char is equals to 97 minus 32 or space. Right, so the answer would probably be A, or uppercase A. And then since 97 is equivalent to lowercase a, and space is equivalent to 32, and 32 is since for space. And right, so let's have char A minus space Alright, so let's continue. Okay, so let's have char is equals to lowercase a, then minus space, or equals to 32. So probably the answer would be uppercase A. Right, so now let's have the next slide. One who asks does not err. The programmer writes a program, and the program asks questions. Computer executes the program and provides the answers. The program must be able to act according to the answers it receives. Fortunately, computers know only two kinds of answers. Yes, it is true, and no, this is false. So you will never get a response like I don't know, or probably yes, but I don't know for sure. To ask questions, the C language uses a set of very special operators Let's go through them one by one, illustrating their effects using some simple examples. Alright, so the question is x equals to y. The question are two values equals. To ask this question, we use the equal operator, or x is equals to y. Don't forget this important distinction. Equals is an assignment operator, and equals is a question, are these values equal? And equals is a binary operator with a left side binding. It needs two arguments and check if they are equal. So now let's ask a few more questions, try to guess the answers. Okay, so for the first exercise, we have 2 is equals to 2. So what do you think is the meaning of that? This question is simple. Of course, 2 is equals to 2. The computer will answer true. So for the second question, 1 is equals to 2. So let's check what would be the meaning of that. And this one symbols 2. The answer will be false. So here's the question. Number 3, I is equals to 0. And the meaning of that would be note that we cannot know the answer if we don't know the value is currently stored in the variable I, and if the variable has been changed many times during the execution of your program. The answer to this question can be given only by the computer and only on the runtime. So definitely we currently know we currently not know don't know the answer, since it will depend on the runtime or the execution of the program. So let's have the question is x equals to y. There's another developer who counts white and black sheep separately and falls asleep only when there are exactly twice as many black sheep as white ones. The question will be as follows. Black sheep counter equals 2 times white sheep counter. Due to the low priority of equal operator, this question shall be treated as equivalent to this one. Black sheep counter equals 2 times white sheep counter. Okay, so let's have the question, is x not equal to y? To ask this question, we use the exclamation equal. It's a very close relative to equal operation. It's also a binary operator and has the same low priority. Imagine that we want to ask whether the number of days left to the end of the road is currently not equal to 0. So here, the example of this is days until the end of the road not equal or exclamation equal 0. Answer is true, gives us the chance to go to the theater or visit our friends. So here's the question, is x greater than y? You can ask this question by using greater than operator. If you want to know if there's a more black sheep and white ones, you can write it as follows. The answer true confirms the statement, the answer false denies it. Okay, so the example for the snippet would be black sheep greater than white sheep. So question is x greater than or equal y? The greater than operator has another special, not the strict variant, but it is noted differently in classical arithmetic notation, which is uh, greater than or equal. There are two subsequent signs, not one, both of these operators, strict and non-strict, as well as the other two as we discussed. The next section are binary operators with left side binding, and their priority is greater than the ones indicated by equals and not equals or exclamation equal. If we want to find out whether or not we have to wear a warm hat, we ask the following question. Centigrade outside greater equal 0.0. Alright, so now let's have the next slide. The question is x less than or equals to y. As you probably already guessed, the operators we use in this case are the less than operator and its not strictly sibling, and less than or equal. Look at this simple example. We're going to check if there's a risk that will be defined by the highway police. So here's the first question is strict and the second one is not. So here the current velocity is equivalent is less than 110 and current velocity is less than or equal 110. So this one is strict and this one is not. So I'll have to use the answer we got. What can we do with the answer we get from the computer? There are at least two possibilities. First, we can memorize it and make use of it later. And how do we do that? Well, we use an arbitrary variable of type int like this. Int answer value 1 and value 2 answer is equals to value 1 less than and greater than equal value 2. If the answer is true, because value 1 is greater than or equal to value 2, the computer will assign 1 to answer. 1 is arguably different from 0. If value 1 is less than value 2, the variable answer will be assigned 0. So the priority table is, so this is the one that priority table, updated priority table, and I think this is the complete priority table. The second possibility is more convenient and far more common. We can use the answer to make a decision about the future of our program. We use a special instruction for this purpose, and we will try and tell you what that is very soon. Now we need to update our priority table. It now looks as follows. So we have unary plus and minus, unary multiplication, division, and modulus, and we have binary plus minus, greater than, equal, less than, equal, exclamation equal or not equal, equals, plus equal, minus equal, times equal, divide equals, and modulus equals. So now we have a condition and conditional execution. You already know how to ask, but you still don't know how to make a reasonable use of answers. We must have a mechanism which allows us to do something if a condition is met, and not to do if it is not. It is just like a life. We do certain things, or we don't when a specific condition is met or not. We go for our walk if the weather is good, or stay home if it is wet and cold. To make this decision, the C language is a special instruction due to its nature and its application. It is called conditional instruction or conditional statement. There are several variants of the conditional instruction. Well, start with the simplest and slow moving on the more difficult ones. The first form of conditional statement, which you can see below, it is written very informally but figuratively. So if true or not, do this if true. So this is just an example of a conditional instruction. So let's have the next slide, and here another conditional statement, if true or not, do this if true. This conditional statement consists of the following strictly unnecessary elements, and this is order only. If keyword, left opening parenthesis, an expression, a question or an answer, whose value will be interpreted solely in terms of true when its value is non-zero, and false when it's equals to 0. So write closing parentheses. And then in section only 1, but we will learn how to deal with that limitation. So here, if is the keyword, this is a reserved keyword. And then if this, it will be followed in the opening parenthesis, and then the expression, and then close parenthesis, and then the next instruction. So how does this statement work? If the true or not expression enclosed inside the parenthesis represents the truth, example, if it is the value is not equal to 0, then the statement behind the condition do this if true will be executed. Okay, so if not, then sometimes we will have the condition statement of if and else, then if and then. So if the true or not expression represents falsehood, its value is equal to 0. The statement behind its condition is omitted, and the next executed instruction will be one that lies after the conditional statement. In real life, we often express a will. If the statement is good, we will walk next. For a walk next, we will have lunch. As you can see, having a lunch is not a conditional activity and doesn't depend on the weather. What knowing what conditions influence our behavior, assuming that we have the parameterless function, which is go for a walk, then open and close parentheses, and have lunch, open parentheses. Here you can write the following snippet. So let's have the conditional statement for if weather is cold, go for a walk, then have a lunch. Okay, so that would be probably the um, the snippet for the situation like this one. Okay, so let's have the next slide. So as we already know, our friend developer falls asleep and he counts 120 sheep. His sleep is implemented as a special function named sleep and dream. And this function does not require any parameters. We can read it as if sheep is greater than or equal to 120, then fall asleep and dream. We've said that there may be only one statement after the if statement. When we have conditionally execute more than one instruction, we need to use braces. Open curly braces. Take note of this. This is curly braces, which create a structure known as compound statement or a block. The block is treated as a single instruction by the compiler. This is how we circumvent the if statement limitation. Let's treat our programmer a little nicer. So here in this snippet, if ship counter is greater than or equal 120, then let's have start the execution of if else here. After after this conditional statement, then you will open this curly bracket. Okay, so make a bed, take a shower, sleep and dream. Then or else feed the sheepdogs. Okay. So now it's time to some stylistic remarks. Writing blocks one after the other is of course syntaxically correct but very inelegant. It may cause the text of our program to run outside the right margin of the editor. There are few styles of coding the blocks. We won't try to argue that some of them are better than others, but we will be using K and R styles. The letters K and R are initially from the creators of the C language, Mr. Carnegie and Mr. Ritchie. They represent these styles in the classic book and we will follow it. And same snippet in accordance with the K and R style will look as follows. So difference with this snippet, it is continuously written. So here, the same snippet written in the second snippet is we add some tab here after the braces, curly braces. So just like for this example, you will be probably be uh, confused in the code. But here, as you can see here, the if else is out of the margin, and one tab for this one is inside the curly braces. So that would be a good format. So we will use K and R styles. So note that the conditional executed block is indented. It improves the readability of the program and manifests its conditional nature. But by the way, this snippet and the first snippet and the second snippet will have the same output. But in order for you to um, improves the readability of the program, then we should choose K&R style. In the next section, we are going to discuss another variant of conditional statement, which also allows you to perform an action only when the condition is not met. Now, feature shape dogs, please. They've been waiting pages for your attention. Right. So for the next page, we will talk about input and output. So now we're going to set aside conditional statements for a while and spend some more time on two important and extremely useful features we use to provide connectivity between computer and the outside world. Sending data in the direction from human or user to the computer program is called input. The stream of data is transferred in the opposite direction, example from the computer to human, is called output. You've already learned about one function which serves to output data, but can you always remember its name? Yes, it's the puts function, and we use it in very first program we wrote in C language. The puts function capabilities aren't really all that stunning. It can write a string on a computer screen and nothing else. You must not use it if you want to print an integer value or a single character. Why? Because of impairment of the puts function. Its argument can only be a string, more precisely data type of character. But don't confuse by this. We're going to tell you more about it soon. No other parameters will be accepted. So the compiler will be unrelenting and it will not compile such program. So what would what should we do if we wish to output a value of type int or float or char? To accomplish this and even more complex task, there is a very powerful function in the C language named printf or print formatted. This function can easily output several values of different types and mix them with the text. We can show you all of its capabilities now because firstly there are many and secondly we still lack some theoretical foundation to understand many of them. The printf function has several unique features. It doesn't specify how many arguments must be provided. The only requirement is that there must be one at least argument. Additionally, only the first argument has a strict type. It must be a string. Also, all subsequent arguments may be of any type. It is not sorcery. The C language enables us to write this function ourselves. The first mandatory argument is called the format. It's a recipe of the specification according to which the printf function will proceed with its subsequent argument. Uh, printf reads the instruction carefully and learns from it which data is to be printed and how it should be presented to the user. Let's look at it in the three applications. The first is simple. We tell printf to print some text. We do it like this. Printf, this is just the text. See now that the printf function is invoked with two arguments. The first is the format, the second is the variable of the int. Take a look at the format. There's a suspicious character there. Modulus. What is this mysterious percent intended for? Oh, percent. This is percent. What is this mysterious percent intended for? If there is a percent symbol inside the format, the printf considers it a hint on how to proceed with the argument formatting the format. The first hint refers to the first argument after the format, the second to the second, etc. But there are some exceptions to this rule. The percent joined together with some other characters is sometimes called a specifier. In the example here below, the format contains one specifier. So here we will have a printf shift counted so far is %d. So by the way, guys, that %d represents for integer, so that would be the specifier for integer, and the variable for integer is shift counter. So letter T indicates the corresponding argument that should be treated as a value of type in and sent to the screen as a number. And let's have a look at the abbreviated list of the specifier now. The complete list is much more exhaustive, while the general form of the specifier is far more complex and gives more opportunities to deal with the look of the shape of the type and represented. So here we will take a look of the more specifier according to its data type. So for %t, as in decimal, specify the corresponding argument for the value of type int and should be represented as a fixed point decimal number. Its synonym is a %i specifier as in integer. So we can use %d or %i, that would be the same. So %x as in hexadecimal specifies that the corresponding argument is a value of type int and uh, should be presented as a fixed point hexadecimal number. So here let's have %o as in octal. Specify that the corresponding argument is a value of type int and should be presented as a fixed point octal number. And we have %c as in char or character. Specifies the corresponding argument is a value of type int or char and should be presented as a character. So let's have %f as in float. Specify that the corresponding argument is a value of type float and should be presented as a single precision floating point number. And let's have %lf. Specify that the corresponding argument is a value of double and should be represented as a double precision floating point number. Do you remember the difference between float and double? You probably remember that the main difference is the precision. A double is the double size of the float, and the size of the float is 4 bytes, while the size of double is 8 bytes. So which means double has a higher precision than float, but it also takes up more memory and is slower. You may ask how to display a person sign itself if this character is treated as the start of the specifier. The answer is perhaps not all that obvious. In this case, you need to write 2% sign and side by side. We can also consider it to be specifier, so let's add it in the list. So percent as in its sub-specified percent sign. Right. We'll take a look at this example editor. The printf function performs the following work for us: analyzes the format, and when it doesn't encounter any specifiers, put the string. The here on the string here and at this point, printf encounters a specifier and learns from it, and there's an int which should be displayed as a decimal number. It retrieves the value at the first argument after the format um, variable var int. So here, as you can see, the var in should is the is the first variable which is written after the double quote, which is here. So let's have printf resumes following the format and displays a string. The ranges is denoted as. So after this one, the ranges, the printf continues its its statement. The range is denoted as. Then another value would be inserted here, which is varchar here after, and that would be r. So the value would be here is r, and while pi is equivalent to float, which is the value of this is here. So let's try to run this program. So here the year is 2012. Since why we get 2012, since that is declared uh, above the printf statement. And let's have the derivatives of the ranges denoted as r here. It's like it was there as here, and while pi is equivalent to 3.1415, right? So let's continue. Here the printf resumes from viewing the format and displays the string while pi is equals to. In the next and the last specifier requires it to display float value, which is taken from the third increment after the format var float. In effect, the following string will be appeared on the screen here, like this one. So note that the format contains almost exclusively specified three of them to be exact. This means that you have to deliver three arguments for the format. In our example in the editor, this is done by repeating the same variable's name 3 times. It's correct in every respect. Executing this program will output the same variable, or more precisely its value 31, or 3 times once as decimal number, once as hexadecimal, and then once an octal number. As a result, the screen will show the following string: 31, 1F31, F37. Okay, so as you can see here, let's have printf. So let's identify what do you think is the output for this one. So %d. So let's take a look. What is the first variable? It is equivalent to I, and I is equivalent to 31, which is right, and %x here. So we are going to just convert, since this is decimal, we are going to convert it to hexadecimal, and %x represent to hexadecimal, and for this one is octal. So that would be probably the result for this program. Okay, so 31, 1F, and 37. Okay, so frequently made mistakes. Let's now try to think what mistake we can make here and what their consequences might be. We will show you some typical errors for the mistake one. There are more format specifiers than argument. So there are 3 specifiers but only 2 arguments. So here's the specifier, but we only have 2 arguments. So this will probably give you an error. The last specifier is missing its argument. If your compiler is clever enough, it will pay attention to this. Most modern compilers do. However, if your compiler is rather clumsy, you won't get any warning, and when you start program, value printed for orphaned specifier will be completely random. So take note of that. If you have a specifier, then you should have an argument. How about mistake number 2? There is fewer format specifier than argument. Vice versa. If you have specifier, then it should. If you have one specifier, then you should only have one argument. If the Compiler doesn't warn you. The compilation will finish with no offset. Nothing bad will happen during the execution. The argument for the missing specifier will simply not be displayed. But uh, it is okay to have more argument than specifier, but in order to make sure that the compiler will run the right code or the right output for you, then it should have what would be the number of the specifier, then the number of the then you will have the number of the arguments too. So let's have the third mistake. The type announced by the specifier is different from the type of corresponding argument. Int 1 I is equals to 100, print f, then I. The specifier requires a float, but you've provided a variable type of int. So since percent %f is a specifier for float, but your given data is only an integer. If the compiler doesn't notice the value that will be printed on the screen at the runtime will really surprise you. It will have a little to do with the actual value of the variable, which is associated with the different representation of the float data of the computer memory. So to make sure that you have a right data type and the right specifier assigned to each other. So let's have fourth mistake, a slightly less dramatic example. You demand an int that you provided a char. So we'll have char c, and c is equals to question mark. Okay, so since d is or is a specifier for integer, but you declare a char data type, then uh, but we will have nothing bad happen. Why? Not long ago, we said that the data type char is treated as an integer data. If you deliver the character valuable to the printf function but request a decimal to be shown, the printf will output an ASCII code of the character which was used in the corresponding argument. So if the specifier is integer but your data type is C, it will probably give you an output that is equivalent to ASCII code. So one issue still needs some additional explanation. The string sent to the screen by printf function will appear character by character, and if you don't request it explicitly, it will follow the entire line from the left to right margin of the screen or the window. So the following two invocations. So here let's have printf. This is the phrase number 1. This is the phrase number 2. Printf. This is the phrase number 3. So we'll produce a continuous line, maybe spanned over more than one row, filled with text. Now this is phrase 1, this is phrase 2, and this is phrase 3. We'll show you a solution chart to explain the way in which it works. So if you like to have a new line, then we will have to escape operator, which is \n. This represents for a new line, and printf. This is phrase 1, the new line here. So as you can see in the output, we have a new line. So this is phrase number 2. So that was printed to the next line because of this character of this escape operators, and have a double new line. So we have space, then space, another space here. Another line here. This is phrase number 3. Can you explain the empty line came? So the empty line came from because we have a double new line here. So input, of course, is equal important as data output is data output. Actually, it's difficult to imagine any complex program that does not require any data from the user, although you could do in a carefree way, encode all the data needed inside a source code. It's sometimes called hard coding, you need to repeat the execution of the program with other data. You just modify the program, compile it, and run it again. It is not partic- it is not this is not particularly convenient solution. It's far better to get information from the user, transfer it to the program, and then use it for the calculations. How can the C language program can get any data from the human and store it in variables? As in most cases, if you need to perform some complex operations, you should begin a search for the function that performs this task, and only if such a function doesn't exist should you write it on your own. In this case, however, we're lucky the function used for the data input already exists and easily available. The function is named scanf or scan formatted and is a close relative to printf function. Where did this relationship come from? You will see soon. So imagine that we want to ask the user a maximum number of the sheep that we want to count before the developer falls asleep. The user enters the value from the keyboard and the program stores in the specified variable. An appropriate scanf invocation looks as follows. So scanf, so this should be a number, and after this one, this would be an argument. So as you can see, we will have ampersand, and ampersand is for scanf. So we will just add ampersand after before the argument, which is the variable here. So let's have, perhaps you will see the similarity of the printf. The first parameter is also a format that tells the function which data will be given to the program and in which form. As before, we give arguments for the formats in the amount equal to the number of the given specifier. At this point, the similarities end and different begin. First, the argument for the print may not be a variable. It may be an expression as well. Take a look here. As you print here, present t, then 2 times I. Here, we would like to print a double value of I. This is visible using scanf specifier. We must explicitly specify the variable that is able to store data entered by a user. This, however, is not the end of the differences. Okay, so let's have the next slide. So look at the scanf function invocation once again. So scanf, then present t, then end marksheet. You see the odd and ampersand sign in front of the variable marksheet. It's not a coincidence, forgive us, but at this stage of your education, our explanation of this phenomenon will be rather simplistic. Actually, this is part of more general and rather complex issue that we want to discuss later. For now, we will tell you that whenever you use a variable name in the program or just like marksheet, you use the value that is variable in the currently storing. However, the interests of the scanf function are different. It is not all the interested it is not all interested in the variable's function value because it will soon be replaced by one the user enters. Okay, so scanf is to something completely different. It's precisely where is the variable placed in the memory. The memories and the mysterious ampersand is a binary operator which gives the information about its argument location. In the scanf's format provides information about the type of data, while the ampersand also, along with the variable name, says where it has to be placed. Leaving out the ampersand doesn't cause any problem during the compilation, so therefore you have to remember that scanf essentially needs it and cannot operate without ampersand. So without ampersand, you cannot operate the scanf. Furthermore, the scanf format uses the same specifiers as printf. This should be bring to you as I already. Now we will show a simple yet complete program that does not follow this that does the following. So the first one is prompts the user to enter the single integer value. So let's run this one. What do you think this program will give us the result? what do you think this program will prompt us? Okay, so give me a number and I will square it. So let's have 255. Oh, sweet for a sec. Let's have 255. Okay. Okay, so here the compiler scan the integer that I enter, which is stands for the value. This is the variable that I enter, and as you can see, we have two variable, which is the value on which the computer prompts me what would be the value or the integer I will give to them or input to it. And the second variable is the square on which the this would be the variable for the solution on how to square a value. So here, square a value times value. So as you can see, square is multiply by itself. So we have the equation value times value. So I enter 255 times 255. So probably will give me a 65025 value. So the compiler give me another statement. You've given me 255, which is the value, and another print, which is this one. The squared value is percent %d, then enter, and then square. So here, so what do you think? This format is right. So this program gives a right output. So here squares it and print the value with the appropriate comment. We assure you that analyzing this program, right? So if you have any question, then you can message me on Cisco inbox. Right, so let's have another one. Do you prefer squares? No problem, but we need to remember two things first. There's no such thing as a square root operator. Second, square roots of negative numbers does not do not exist. We can resolve the former issue by finding a function that knows how to compute the root. The function existed and takes an argument of type float, and the result is also a float. Obviously, the square of an integer is still an integer, but the root of any number is not always an integer like the square root of 2. The function we're going to use is called sqrt, or square root float, and requires just one argument. Oh, one more thing. To use this function, you must include a header file named math.h. So here, as you can see, we add another header, which is hash included math.h. So we need to deal with the negative numbers as well. If you are reckless as to provide a negative number, the program will just ignore you and your input completely. It may not be polite, but at least we won't be trying to bend the rules of the mathematics. Whether we see the result or not will be decided by the conditional statement. So now direct your attention to the use of floating data in this QRT function, and the program is in the editor. So here the first statement would be the header, which is the stdio. Then the next one, as we already mentioned, that we will add math.h. Then it will prompt us or give us another statement, which is the function, which is the name of the function, which is main, and this is be void. And another one is to declare the value, the variable in the data type. First is the data type, then what would be the variable names that we will be using in the program. And here, as you can see, the program wants us the program will prompt us give a number and I will find the square root. So here, as you can see, how about 16? Okay, so here, um, the compiler will scan the float or the square that the value that I gave, which is the value here. And the first one is if, so that would be this is a conditional statement if you already see if here value is equals to greater or equals to 0 0.0, the square is equals to square our value, and here printf you have given me what would be the integer that you have. Am I sharing my screen? Oh, come on. Sorry guys, I forgot to share my screen with you. So let's have here, let's go to the previous slide. I will show you how I will explain to you this program. Okay, so the first one we will show you a simple yet complete program that does not the following. First is prompts the user to enter an integer value. So here, as you can see, the program prompts me give a number and I will square it. So here, as I run it, I will give 255, and then it will prompt you given me 255 and the square value is 65025. Then after the compiler will prompt me this one, then the compiler will scan this, and just like the format, it is %d and the value. So after that, then you probably think what would be the the format, or how we will get the square root of that. Then it should be value times value, and as we know that value times to its value would be the square of the square of that. And for the another statement, it would print as you've given me %t and enter, or the new line here. So it would probably give us what I've entered earlier, which is 255 here. And another statement says that a printf that squares the value of is %t. So that would be the probably the result, which is the square, or on how if you are thinking how do we get that output, because we already declare on how to compute that square. So here another slide for format program. Do you prefer square roots to squares? No problem. But we need to remember two things. First, there's no such thing as square root operator. Second, square roots of the negative numbers do not exist. We can resolve the former issue by finding a function that knows how to compute the root. This function exists and takes an argument type float. The result is also a float. Obviously, the square of the integer is still an integer, but the root of any number is not always an integer, like the square root of 2. The function we're always going to use is called sqrt, or square root float, and it requires just one argument. Oh, one more thing. To use this function, you must include header file name math.h. So as you can see on this program, we add the header in hash include math.h. So we need to deal with the negative number as well. If your reckless is to provide a negative number, the program will just ignore you in your input completely. It may not be polite, but at least we won't be trying to bend the rules of mathematics. Whether we use the result or not will be decided by conditional statement. Now direct your attention to the use of floating point data in SQRT function. So the program is in the editor. So as you can see, we declare a data type which is float, and the variable when we have two variable names, the value and the square root. So the program will probably from us give me a number and I will find a square root. Then after the user will input a value, then the compiler will scan. Then since the value is a float, then it should be %f. Then our value that we have input for the program names a value, and we should add ampersand. And all right guys, so as you can see here, we have conditional statement, if conditional statement, and here's the condition value greater than equal 0 0.0 squared is equals to sqrt value. Then printf, I remember guys that sqrt is a keyword for a math, so this would be a square root float. So here printf, you have given me in the next statement, it will prompt as you have given me what is the inputted value, and here the square root should be square root should be all right, so square root is %f, which is square root. And how do we get that the result? The format would be, or the equation should be, square root is equals to sqrt, then the value. So here, let's find out. How about 60? Should enter here. So the square root is 4.000. So the question is, why our result or the output or the final output is equivalent to 4.00, since our data type is a float, not an integer. So let's have the next slide. All right, so this is our quiz 2. So now guys, please answer the quiz 2, and after that proceed to module 2 test, and after that we will proceed to our next module, which is module 3, and uh, discuss the flow control, more data types, and computer logic. So guys, I think the module 2 quiz and test have a 70% passing rate. So good luck guys, and see you in the next module. Okay, good morning guys once again. So now let's continue to the module 3. So in this module, we will learn about conditional execution, the else branch, the integer and float types, conversion, typecast, and its operators, loops like while, do, and for, controlling the loop execution, break and continue, and the logical in bitwise operators. So the conditional statement, more conditional than before, we conclude our last discussion on conditional statements with the promise that we would introduce a more complex and flexible forms. So we started at our tail with a simple phrase, which read, if the weather is good, we will go for a walk. Note that there is not a word about what will happen if it's rain, cats, and dogs. We only know that we certainly won't go outdoors, but what we would do instead isn't mention it. We may want to plan something in case of bad weather too. We can say, for example, if the weather is good, we will go for a walk. Otherwise, we will go to the theater. This sentence makes our plan more resistant to the whims of fate. We know what we will do if the conditions are met, and we know what we will do if not everything goes our way. In other words, we have a plan B. Luckily, this language allows us to express alternative plans. We do this with a second, slightly more complex from the of the conditional statement. Here it is: if true or false condition, perform if condition is true, then else perform if condition is false. Thus, we have a new word else. This is a keyword or a reserved keyword. A statement which begins with else tells us what to do if the condition specified for if is not met. So if else execution goes as follows: if the condition if the condition is true, its value is not equal to zero. The perform if condition is true is executed and the condition statement comes to an end. If the condition is false, its value is equal to zero. The perform if condition false is execution and the condition statement comes to an end. Okay, so let's have this next slide. By using this form of the conditional statement, we can describe our plans as follows. If the weather is good, then go for a walk. Else, go to a theater, have lunch. So let's have here this one. If this is the condition, if the weather is good, then if it is true, if this condition is true, then we will, if the condition is true, then we will have this one. We will do this one. And else, if it is false, if the condition is false, then we will do this one. Okay, so as well as in other simplified forms of the instruction, like the ones we've already encountered, both if and else may contain only one statement. If you're going to write more than one instruction, you may to use block as in example below. So this is the example of block if you want to add more statement. So here, if weather is good, go for a walk and have fun. So we can execute out more than one statement. So else, then go to a theater, enjoy the movie. So that would probably an example of more than one statement of if else condition. So now let's discuss two special cases of the conditional statement. First, consider the surprising case when the instruction placed after the if is another if. Listen to what we have planned for this Sunday. If the weather is fine, we will go for a walk. If we find a nice restaurant, we'll have a lunch there. Otherwise, we will eat a sandwich. If the weather is poor, we will go to the theater. If there is no tickets, we'll go shopping in the nearest mall. So here, so as you evaluate this conditional paragraph, as you can see, if the weather is fine, here if the weather is good, we will go for a walk. And then if we find a nice restaurant, then here another if again if we find a nice restaurant, we'll have a lunch there here. Then otherwise we will eat sandwich here. So this is another if if else condition. Else, if a ticket is available, go to theater. Else, if not, if tickets are not available, go to shopping. So here, let's examine two important points, such a use of the if statement is knowing as nesting. Remember that everything else refers to the closest form. If which did not match any other else, we need to know this to determine how the ifs and else pair up. Consider how the indentation improves readability and emphasizes the nesting of inner conditional statements. The second special case slightly resembles nesting, but there aren't many more similarities. Again, we will change our plans and express them as follows. If the weather is fine, we will go for a walk. Otherwise, if we get a ticket, we'll go to the theater. Otherwise, if there are free tables at the restaurant, we will go for lunch. If everything fails, we'll return home and play chess. So here we have a different plan, or an alternative plan. So here, did you notice how many different alternatives there are? Let's write the same scenario in the C language. Okay, so here's the condition. If the weather is good, go for a walk. Else, if not, if the weather is not good, then um, then we have tickets are available, then go to theater. If not, else if, then use else if. Okay, let's use else if there's any alternative option for the condition. So here, as if if a table available, goes for lunch. Else, this is the probably the last. Else, if if the last alternative, if if it is on the last alternative, then use else only. Yeah, here, play chess at home. So this way of assembling subsequent if statement is called cascade. Notice how the intention improves the readability of the code. Now let our mind work out, and we've told them about conditional statements. While we pay attention to our old friends' types at in, char, and float, we're going to meet their siblings. Not only the int is an int, it would seem that the developer's life would be organized well enough if they had type int to operate with integers, type char to manipulate characters, and type float for floating point calculations. However, this practice has shown us that just a narrow repertoire repertoire of types may raise some problems. Most of the computers currently in use store int using 32 bits or 4 bytes. This means that we can operate the int with, within the range of negative 2147483648 to 1474836. This is on a negative, this is on positive. It may happen what? It may happen that we don't need such big values if we count. It's unlikely that you'll need to count 2 billion of them, so why waste the majority of these 32 bits if we don't need them? We need much larger values. For example, we intend to calculate the exact number of humans living on Earth. In this case, we need more than 32 bits to represent that number. This brings us to another observation. After all, the number of inhabitants on Earth will never be a negative number. It seems a real waste that up that up to half of the permissible range will never be used. For this reason, the C language provides that method for defining precisely how we can store large small numbers. This allows the compiler to allocate memory either smaller than usual, it's like 16 bits instead of 32 bits, or larger than usual, 64 bits instead of 32. So we can also declare that we guarantee that the value stored in the variable will not be non-negative. In this case, the width of the variable's range does not change, but is shifted towards the possible the positive number. This this means that that instead of the range of negative 2147483 648 or 2147483 647, you get the range of 0.42994967295. So as you can see in the image here, if we have smaller bits, then we have we can only store small numbers, while if we have bigger bits, then we can store larger numbers. So here, to specify our memory requirements, we can use some additional keywords like modifier. So here, long is used to declare that we need a wider range of ints than the standard one. Short is one to determine that we need a narrower range of int than the standard one. Unsigned is used to specify that variable is needed only for negative numbers. Although it may surprising, we can use this modifier together with the type char. We will explain how soon. Note that some compilers may not be able to distinguish data of types int and long. They may be synonyms. If you want to force the compiler to use actual long representation for a specific number, you can use the long type. Let's look at the example. For example number 1, the counter variable will use fewer bits than the standard int. It could be 16 bits long. The range of the variable will be suppressed to the range of, okay, so it is more, it is more uh, larger. The short int counter, the word int may be omitted as all the declarations are considered to be specified int by default, like this short counter. So instead of saying or writing short int counter, you can write it as short counter. So the ands variable will occupy more bits than the standard int. So it can be used to store numbers from the range of -9 to 3. Okay, so can you read such huge numbers? Long in ants. So note we can again omit the word int. So long ant. So we can omit int word, int keyword. So let's have example number 3. If we use to come with the conclusion that the variable will never be a negative value, we can use the unsigned modifier. So here in the snippet, as you can see, unsigned int positive. Of course, you can omit the int as usual, unsigned positive. So for example, we can also mix some of the modifiers together. Take a look. Unsigned long int use huge number. We can remove the word int and declaration will be preserved its meaning. Unsigned long huge number. So definitely there are modifiers for three modifiers for int, and that would be long, short, and unsigned. And if we are going to use that, we can omit the keyword int. So here another one, for example number 5, more modest example is here unsigned short int lamps. It is equivalent to unsigned short lamps, so we already omit int keyword. So here, the long and the short modifiers must not be used in the conjunction with the type char. Why? And for obvious reason must not be used simultaneously in a single declaration, but there's nothing preventing us from using the unsigned modifier with the variable type char. What do we get from this declaration? Don't forget that we're not allowed to omit the word char, because the compiler is currently in use to assume that chars are stored in 8 bits or 1 byte that may be stored to store a small value such as the number of the months or even the day of the month. If we treated a char variable as a signed integer number, its range would be negative 128 or 127 if we don't need any sign value. As in the example below, its range shifts to 0 to 255. This may be sufficient for many applications and may also result in significant savings in memory usage. So here in this example, unsigned char literal counter, don't omit the word, the data type char. So, but we need to add important remarks. So, for we've used integer literals, assuming that all of them are of type int. This is generally the case, but there are some cases when the compiler recognizes literals of type long. This will happen if a literal value goes in beyond the beyond the acceptable range of type int. The letter L or I is appended to the literal such as uh, 0L or 19811. Both of these literals are of type long. Another float type, the short type modifier cannot be used alongside to the float, but we will use the long modifier here. It's assumed that the type long float is a synonym for another type named double. The variables of type double may differ from the variables of type float, not only in the range but also in accuracy. So the long float and the double are have the same. Okay, so what does this mean? The data stored in the floating point variable has finite precision. In other words, other only a certain numbers of digits are precisely stored in the variable. For example, we expect that the value is okay, so that too long number will be inserted by a specific type of computer as 111113151653120.00. We say that the variable saves only 8 precise digits. This is within the expected accuracy of 32-bit long float using a double, which is usually 64-bit long, guarantees that the variable will save a more significant number of digits, about 15 to 17. This is where the name double comes from, and its accuracy is doubled compared to float. So here, the float and their traits. So we told you some time ago that the computer addition is not always commutative. Do you know why? Imagine that you have to add a large number of floating points values. Some of them are very large, some are very small, close to zero. If a very small float value is added to another that's very large, the result can be quite surprising. But back. Let's go back to the previous example. We'll assume that our computer only saves 8 precise digits of any float. If if we add this two floats, we'll probably get 111111065.6.000. As the result, the lower values seem to vanish without a trace. We can avoid these effects when we add subtract the numbers of type float and of double as well, because they are also affected by this issue. The phenomenon described here is what we call numerical anomaly. In conclusion, the C language is not allowed to use of short and sign modifiers along the types of float and doubles. Okay, don't forget about it that we are not allowed to use short and unsigned modifiers alongside types of data types of float and double. So let's have metamorphosis or conversion of data. The multitude of data types in C language may cause some confusion, especially when different data types appear together inside one expression. Now it's time to talk about this thoroughly. Let's start with a definition. Changing the type of the data is called conversion. Okay, take note of that. Changing the type of data is called conversion. So the C language knows two types of conversion. The first one is implicit conversion, which work accordingly to language rules and are not specified in the code in any variable way. Their operation is silent and automatic. Ex- okay, let's start explicit conversions carried out of the developer's request. The developer should insert them explicitly inside the code indicating which value should be converted and into which resulting type. Implicit conversions are performed at the runtime according to these strict rules. The rules are applied in order below until all the data used in the particular expression has the same type. This condition is very important. Data type char or short int will be converted into to the type int. This is called an integer promotion. And if there is any value of type value in expression, the other data will be converted to float. If there's any value of data double in the expression, the other data will be converted to double. If there's any value of type long int in the expression, the other data will be converted to long int. Okay, so if the context in which the expression is calculated requires another type than the one resulting from the implicit conversion, the last conversion is done to the type requested by the context. Explicit conversion are introduced to the code using the typecast operator. This is a unary operator with a higher priority equal to unary minus. You can see it here. Okay, sino yun? Type value, where type is a name or description of the type which the value will be converted into. For example, in the following snippet, the value x of type float is explicitly converted into the double type float x. So we have declare two data types here. This is float, and the double and float for the variable name is x, and for the double data type will be y. So y is equals to double then x. So because we've introduced a new operator, we need to update the priority table. Here it is. So here another priority table. So here the type, then plus plus minus minus plus minus, and then time multiplication, division, and modulus for unary, for binary plus minus, um, greater, less than greater equal, then greater than greater than equal, then exclamation point, then equal or not equal, and equal plus equal or minus equal, then times equal, divide equal, then modulus equal. So that would be the updated priority table. For typecasting, we will continue knowing how implicit conversion, sometimes called automatic work. Well, we will analyze the process of calculating the value of the expression in the following snippet. And we have declare for data types here, for different data types here. And that would be int, char, short, and float. Int is equals to short plus char plus float. We can predict that the following implicit conversion will take place. So promotion to go first, resulting in the following conversion. Int short plus int, then char. The sum of the short and the char as well as the float variable will be converted to float, that is. So here float int, so int short, so we are going to multiply this one plus int then char, so we are going also to multiply this one, then we will add it, and after that we will multiply it to the float, then add it to the float for this one and add it to this one. So the final answer will be calculated as a float, but because of the context arising from the type of the left argument, the equal operator, which is in another conversion to an int type, takes place. Hence, the final form of the expression look like this: int then int float plus int char plus float. Okay. So here another. So here are some simple programs. So now we are going to show you some simple yet complete programs. We won't explain them in detail because we think that comments inside the code should be enough for you to get it. All the programs perform the same task. They find the largest of the several numbers and print it out. Let's start with simplest case, how to identify the larger of the two numbers. So here, okay, so finding the larger of the two numbers. So that would be the title of our program, and we will of course start with the header, this hash include stdio.h. So this would be the function name, and we should declare the two numbers, and the data types of the two numbers would be int, integer, or let's use keyword int, and the two variable names are number one and number two, and then we will save the larger number here. So we use three variable names, so that would be number one, number two, and max. So uh, we can also write it by in number one, number two, and max, but in this case we probably uh, declare it separately since we have a comment, and just for you to understand it. And for this one, scanf present uh, d then number one. So we have scan number one, which is integer, and scan d another integer. So we have temporarily assumed that the former number is the larger one. We will check it soon. So here max is equals to check to number one, then we check if the assumption was true. If number two is equals to max, then max is equals to number two, then we print the result. The largest number is percent %d, then we finish the program successfully. So let's try it. Okay, one more time. Oh, so this it will print anything since we the we can't why how can we scan how can we use scanf if the user don't input anything in this case. So probably should add another line here to um we should add another line for printf of number one and two. Just so here for another program, some simple program, let's try to find the largest three numbers. We find the larger of the first two and compare it with the third one. Here we go. So here as we uh, give the title for our program, finding the larger of three numbers. So the first thing that we're going to do is put or write the header, which is hash include stdio. The next one would be declare the function, and then the body of the function, which is here. The first thing that we're going to do is to declare the variables, which is number one, two, and three, and we will also give an int max for variable name for the maximum number. So here read three numbers, which is number one, two, and three. We okay, so here maximum also as you can see here in the command, we temporarily assume that the first number is the largest one. We will check it soon, and for maximum is equals to number one. So they assume it that the larger number would be number one. So if we check in the second value is the largest Then if number 2 is higher than the max, then maximum number is equals to number 2. While just like number 3, that would be also the uh, equation or the statement. If number 3 is greater than max, then max is equals to number 3. So we print that the number larger is percent d and the max. What do you think is uh, of course that would probably give us the number 1. Okay, so as you can see on the console, we cannot see an answer here because the programs didn't give us didn't give the user or didn't prompt the user to input something, right? So this is just an example, not without entering any value from the user. Here another some simple programs. You should be able to write a program that searches for the largest of 4, 5, 6, or even 10 numbers. You already know that format, so extending the program isn't uh, particular complex. But what happens if we ask you to write a program to search for the largest of the 100 numbers? Can you imagine the code? You need hundreds of declaration of int variables. If you think you can cope with that, then try to imagine searching for the greatest of a million numbers. Imagine that the code that contains 99 conditional statement and 100 invocation of the scan function. So what do you think is the answer for this? Of course, the C language will offer us the simply the technique for this. So here, so let's ignore the C language for a moment and try to analyze the problem without thinking about the programming. In other words, let's try to write the algorithm, and when we're happy with that, we'll implement it. We will use a kind of notation which is not a programming language at all. It can be neither compiled nor executed, but it is formalized, concise, and readable. We call it pseudocode. In the editor, there is an example of pseudocode what's happening in it. Firstly, we can simplify our program if at the very beginning of the code we assign the variable max with a value which is smaller than any of the numbers entered, we will use negative 9999999. And secondly, we assume that our algorithm doesn't know in advance how many numbers will be delivered to the program. We expect that the user will enter as many numbers as he or she wants. The algorithm will work well uh, with either the 100 or 1000 numbers. How do we do that? We make a deal with the user. When the value is negative 1 is entered, it will be sent that there is no more data and program should end its work. Otherwise, if the value is entered not equal to negative 1, the program will read another number and so on. So the trick is based on the assumption and that is any part of the code can be performed more than once, in fact as many times as you need it. Performing a certain part of the code more than once is called a loop. You probably know what this means already. See steps number 2 through 5 make a loop. Can we similar structure in the program written in C language? Yes, we can, and we will tell you about it soon. So as you can see here in the editor, so this is a pseudocode. So we don't have the header, we don't have the function name, we don't declare the variable name. So this is just a scratch on how to solve the problem, to write your code according to the problem. So as you said earlier, that instead of typing a scanf up to 1 million or even 100, you can do this a temporarily a temporary a code here. So if maximum is negative 1 is negative 9999, then read number should so how can we make a statement out of this pseudocode? So if number is equals to negative 1, print max, then stop. So if number is equals to, so we are going to make a loop here and an if else conditional statement. So here, the while loop, we want to ask you a strange question. How long do you usually take to wash your hands? Don't you think about it, just answer. Well, when your hands are very dirty, you wash them for a very long time. Otherwise, it takes less time. You then keep washing your hands until they're clean. Look at the statement below. Do you agree with it? While my hands are dirty, I am washing my hands. Note that this also implies that if our hands are clean, we won't wash them at all. So now you've learned one of the loop available in C language. In general, the loop manifests itself as follows: while, the conditional expression, then the statement. If you've noticed some similarities to the if instruction, then a good job. It's it is in fact there's only one syntactic difference. We use the word while instead of if. Okay, so instead of using while, instead of using if, then we will use while. The semantic difference, however, is more important. When the condition is met, if performs its statement once, while repeats the execution as long as the condition evaluates the true. Okay, so that would be the difference between if and while. So if is just one time used for conditioning, and while it repeats its execution as long as the condition evaluates until it becomes true. Okay, look at the concept of the while loop below. So here, as you can see, well, as you can see here, the syntax for while uh, conditional formatting here. A while, then parenthesis, conditional expression, statement one, two, three, and so on. Let's make a few observations. If you want while to execute more than one statement, you must like if the statement if is block. Then take a look at the code of the editor. The instruction executed inside the loop are called loops body. If the condition is false, equals to zero as early as when it's tested from the first time the body is not executed. Even once, noted the analogy of not having to wash your hands if they are not dirty. Okay, so on the first conditioning, if the statement is false, then the body will not the loop will not be executed. uh, the body should be able to change the condition value, because if the condition is true at the beginning, the body might run continuously to infinity. Notice that the washing changes the state of impurity. Right, so here's an example of a loop that can't finish its execution. So if while then one, printf, I am stuck inside the loop. So here, this will be infinitely print. I'm stuck inside the loop on the screen. So this should be infinite printing with this snippet or with this code. Alright, so now let's continue. Let's go back to the sketch of the algorithm we made recently. We're going to show you how to use the new learn loop. Right away, we will introduce you one more thing to you. So far we've declared variables in one place and assigned values to them in another. We can combine this two steps. They declare the values and assign the values at the same time. We do this by adding equal sign followed by an expression whose value is assigned to the variable at the time of its creation. For example, you need a variable that means a value of 0, then you can do this. So we can do this sample. As usual, on such occasion, a new word arrives into a vocabulary. The part of the declaration placed on the right side of the equal sign is called initiator. The initiator so before was a literal, but you can also use more complex expression like this one. So here just called as initiator, but we can also create a initiator that is complex like this one. You'll be using initiator often. They're extremely convenient and quite useful. So a simple program, look at the code editor and analyze it carefully. Locate, locate the loop's body, find out how the body exited. See how the above comment implement the algorithm we made is there. So here, as you can see, on the function body, first one we declare the int number here. So it's a temporary storage for incoming numbers. So the next one is int max negative 100,000. We will store the currently greatest number here, the max. So get the first value number, and this could be done by scanf. And while we will use while is not equals to -1, and if the number is um, greater than max, then max is equals to number. So as you can see here, yes, update the max. So we are going to update the max value, and here you can see get next number. So scan F, then we will after updating, then we will get it by using scanf. Then we will print the largest number is here, and then finish the program by return 0. Okay, as you can see that there's no result in the console, just like we have earlier that uh, the program didn't allow us to input something before this one. So this is probably an example on how to analyze the program carefully. So in order for you to see the output for this one, maybe you can add here some printf and declare some, in order for you to scan the integer. Right, so now let's have to the next slide. So here another program. The program counts odd and even numbers coming from the keyboard. Take a look at the code in the editor. Certain snippets can be simplified without changing the program's behavior. Take a look in the next slide. So the program reads a sequence of number and counts how many numbers are even and odd. The program terminates when 0 is entered. So here events is equals to 0 and odds is equals in number. So store in incoming number here, another one and read the first number, and then while is not equals to 0, then check if the number is odd. Then it will prompt us the statement will be odds plus plus. And then as you can see here, the conditional statement is the modulus number, then modulus 2, then that would be add plus plus, and then else, and if else or otherwise, then it would be increase the even counter, which is evens plus plus. Then going to the next number and will be temporarily stored, and then it will print the even numbers and odd numbers. So here, let's have the while loop in example. Try to recall how the C language interprets the truth of the condition and notes that these two forms are equivalent. While number is not equal to 0, then the conditional body, then while number, then the body. Then the condition that checks if a number is odd can be coded like this. If number modulus 2 equals to 1. And then you can also have if number modulus 2. Nothing would surprise you now, right? But there are two things that can be written more compactly. First, the condition of the while loop. Here, condition of the while loop. As you can see here in the snippet, we have while loop counter is not equals to 0, and then puts I am an awesome program, then counter minus minus. Okay, so let's have another change, another snippet, another change requires some knowledge of how the post decrement works. We can use it to compact our program once again. So here, while counter puts I'm an awesome program, then counter minus minus. So from 5, it will decrement from 0. And then we believe this is the simplest form of the program, but you can challenge us if you dare. So we can also write this code through this one. And it may void in counter is equals to 5, while counter minus minus puts I'm okay. So instead of adding put minus minus here, you can also put that here in order for you to reduce redundancy. Okay, so the do loop or do it and at least once. You already know that the while loop has two important features. The first one is it checks the condition before entering the body, and the body will not be entered if the condition is false. These two properties can often cause unnecessary complication. For this reason, there's another loop in C language which acts as a mirror image of the while loop. We say so because if the loop the condition is checked at the end of the body execution, the loop's body is executed at least once, even if the condition is not met. This loop is called do loop. It's simplified syntax is presented below. Do, just like this one, do statement, then while condition, then do statement 1, 2, 3, and so on, then while condition. If you want to execute a body containing more than one statement, you must use a block. So this is a block. Okay, this is a block starting with curly brackets. Let's go back to the program to search for the largest number. Firstly, we will use the do loop instead of while for teaching purposes. Secondly, we will remove the vulnerability involved in excessively trusting the user's good intentions. Our new program won't be missile by entering the value of -1 as the first number. The program is presented below. So here, this is an example program of using do while loop and with if else. As you can see, we have declared three variables, which is number, max, and counter. So the first thing that the program will do is do, and it will scan the number, the value of the number, which is not yet declare what is the value of it. And if number is not equals to -1, then the counter will be will increment. So the counter from 0 will increment, then it will add 1 and 1. If number is greater than max, then the number is equals to number. Then while number is not equals to 1, if counter printed largest number is blank, and that would be the max. And else, are kidding, you haven't entered. Okay, so take a look. We've used the counter variable to count the numbers entered, so we can tell the user that we can search for the greatest number if no number is given. As we have to read at least one number, it makes sense to use the do loop. This is what we've done here. So here the for loop. The last kind of loop available in C language comes from the observation that sometimes it's more important to count turns of loop or iteration, then to check the conditions. Imagine that a loop's body needs to be executed exactly 100 times. If you had like to use the while loop to do that, it may look like this. So we have declared y as a variable name and I is equals to 0. We can write that int I is equals to 0, and while I is less than 100, and then the body goes here. So the body is increment, is I then increment. We can distinguish three independent elements here. The initialization of the counter, which is I equals to 10, checking the condition I less than 100, and modifying the counter, which is I increment. We can provide something like a generalized scheme for the kinds of loops. Here it is. So this is the scheme for the loops or the syntax. So it would be the initiation or declaring the variable, and then while, and then checking the conditional statement. If it's true, then this is the modifying. If it's true, then if not, if the condition is false, then it will not run the while block. So this way of coding the loop is very common too. There's a very brief way of writing it in C language. All three decisive parts are gathered together. The loop is clear and easy to read. It's called for. So for is another research keyword that is also part of conditional statement. So this is for initialization initialization. So for here, initialization, then checking, then modifying. So the body goes here. So for instead of using uh, declaring here and do the while and doing the, we can use for the having it, and just like this one, instead of writing this code, you can write it as for I is equals to 0, just like this one, and just add semicolon, and then add it, I, and then the increment. Okay, so it won't be interchanged. It will always be declaring initialization, then checking if it's greater than, equal, or less than equal, and then modifying, which is increment or decrement, and other operators. The values for the counting loops are called control variable. So here, the for loop has an interesting singularity. If we omit any of its three components, it pre-assumes that there is a one there instead. So here on the for loop, as you can see, it has two semicolons. As you remember, as we discussed it earlier, that the first thing that you are going to put here and inside the parentheses is the initialization, which is the declaration of the variable and its value. The next one is the second one is checking, and next is modifying. On which here, one of the consequences of this is that a loop written in this way is an infinite loop. Well, the conditional expression is not there, so it's automatically assumed to be true. And because the condition never becomes false, the loop becomes infinite. Let's look at the short program in an editor. It says is to write sum of the first powers of 2. The exp variable is used to control variable in the loop indicates the current value of exponent, and the exponentiation itself is replaced by multiplying by 2. Since 2 to the power of 0 is equals to 1, then 2 times 1 is equals to 2 to the power of 1, then 2 times 2 to the power is equals to 2 to the power of 2, and so on. Answer this question: what is the greatest exponent for which is our program still prints the result. So as you can see, that this is a loop. So it definitely end with 32768 until 15, until to the power of 15. So here on the first part, the initiation, uh, in the initiation, we have declared that exponent is equivalent to 0 and the exponent is less than 16. So we have the limitation here. So um, that's why we limit the output until to the power of 15 because 15 is less than 16. Okay, so we have the increment. Of course, increment means to increase. And for the formula for that, it is pow, which is equals to 1, and then equals to pow, which is 1, then times 2. So here we get a result of this loop, 2 to the power of 0 until 2 to the power of 15. Here, let's have the break and continue the loop spices. So don't forget about this keywords on the keywords in our loop condition or conditional statement. So far, we've treated the body of the loop as an indivisible and inseparable sequence, the instructions that are performed completely at every turn of the loop. However, the developer could be faced with the following choices. It appears that it's unnecessary to continue the loop as a whole. We should refrain the executing the loop's body and go further. It appears that we need to start condition testing without completing the execution of the current turn. The C language provides two special instructions for implementing both of these tasks. Let's say for the sake of accuracy that their existence in the language is not necessary. An experienced programmer can code any algorithm without such instruction. The famous Dutch computer scientist Edsker Dijkstra proved in 1965 additions which don't improve the language's power of expression but only simplify the developer's work are sometimes called syntactic candies. These three instructions are break. First one is break. Break and continue. The first one is break. What is break? This exits the loop immediately and conditionally ends the loop's operation. The program begins to execute the nearest instruction after the loop's body, and then continue. This behaves as if the program has suddenly reached at the end of the body. The end of the loop's body is reached, and the control variables is modified in case of for loops, and the condition expression is tested. Then both these words are keywords. Now we will show you on two simple examples. We'll show you in full power soon. Okay, so we return our program that recognizes the largest among the numbers entered. We will convert it twice using both instruction, analyze the code and judge whether and how you would use any of them. You can see the break variant of the variant in the editor. Note that the only way to exit the body is to perform the break as the loop itself is infinite for for this uh, for loop. Another continue is a variant. So this is a break variant, and now we are going to um, use the break and um, continue keyword. So here, as you can see, we cannot see the continue keyword, but we already use break here. So if this is the case, then for then give the initialization, then checking the modification, then scan the number, and the number is equals to -1. And if this is, remember that this is a if statement, and if number is equals to -1, then it should quickly end the program because it the statement here after the if inside the if is break, which means to end the program. Right. So, but if not, if it is not equals, but if it is not equals to -1 and the number is less than the maximum, then it should execute maximum is equals to number. Great. So let's have the next slide. And now the continue variant. So now let's have the continue keyword used. Okay, so in this case, we already used the continue keyword. Just like we have the example earlier that after the if example, if number is equals to -1, that should be stop the execution because the earlier example gives us the keyword break. So for this example, uh, we definitely see that it is continue. To continue the execution of the program, of course, we will continue. The compiler will continue the execution of the program, which is if the number is equals to -1, then the counter would increment the number, right? So let's have another. Let's have the next slide. Okay, so for the computer logic, have you noticed that the conditions we've used so far have been very simple, not to say quite primitive? The conditions we use in the real life are much more complex. Let's look at the sentence. If we have some free time and the weather is good, we will go for a walk. We've used the conjunction and which means that going for a walk depends on the simultaneous fulfillment of the two conditions in the language of logic. The connection of the condition is called conjunction. And now another example. If you are in the mall or I am in the mall, one of us will buy a gift for mom. The appearance of the word or means that the purchase depends on at least one of these conditions in logic terms. This is called disjunction. So remember that if having and keyword, then that is conjunction, and or then that is defined as disjunction in the logic terms of computer. Then, therefore, the C language must have operators to build conjunction and disjunction without term. The expressive power of the language would be substantially weakened. We call this logical operators. So here, by the way, guys, that for and the logical symbol for that is like this one. And then for not, it would be probably like this. And or it is like this one. So pride and prejudice. The the logical conjunction operator in the C language is a digraph and an ampersand ampersand. This is a binary operator with a priority lower than the comparison operators. It allows us to code complex conditions without the use of parentheses like this one. Counter less than 0 and then value equals 100. The result provided in the end operators can be determined as the basis of truth table if we consider the conjunction left and right and then right. The set possible values of arguments or corresponding value of conjunction looks as follows. So left and then right, then left and right. So here, as you can see, if if false if left is false and right is false, then equivalent of that is false. Then if left is false, then right is false, then equivalent of that is false. And then if left is true, then right is false, then equivalent of that is false. Then if the left is true and the right is true, then the equivalent of that is true. So by the way, guys, that this end is represent this one and the weather is good. If we have some freedom and the weather is good, this is just like this one, left and right. Okay, so let's continue with the computer logic to be or not to be. The disjunction operator is a digraph, a bar and a bar. It's a binary operator with a lower priority than and, just like plus compared to asterisk. Its truth value looks like as follows. So if left is false, then right is false, then equivalent of that is false. And if left is false, then right is false, the equivalent of that is true. Then the left is true, then the right is false, equivalent that of if that is true. And if left is true and the right is true, then equivalent of that is true. So what do you think is the difference between bar and ampersand? So we have, okay, so as you can see, if we are using and, the only true answer for them this is that if the left and right are true, the answer is true. But if we are having same false or having false and true or false, then we will get the the answer false. Well, if we are having bar, we will get the answer. If it is false, then the answer is false. But if we had at least one true, then the answer will be true. All right. So in addition, there's another operator that can be used in the construct conditions. It is a unary operator performing a logical negation. In its operation is simple. It turns true into false and false into true. This operator is written as a single character or exclamation mark, and its priority is very high, the same as the increment and decrement operators. It its truth table is truly simple. So here, so this is logical negation, is arg and exclamation arg. If it's false and true or false. So here, some logical expression. Note that the following conditions are equivalent respectively. Okay, so this condition are equivalent respectively, just like this one, where variable is less than 0, then not, uh, exclamation means not. The variable is greater or equal to 0. So variable is less than 0 and not, and then parenthesis variable greater than equals 0 is the same or equivalent. And then variable is not equals to 0 and not variable equals to 0 are the same. You may remember the Morgan's law from school. They said that the negation of the conjunction is the disjunction of the negation. The negation of this disjunction is the conjunction of the negation. So let's try to write the same thing using the C language. So not P and Q equals to not P, then or bar to be, this is read as to be not Q, and then not P to be Q equals to not P and not Q. So note that how the parentheses have been used to the code of expressions. We should add that none of the previous two argument operators can be used in the abbreviated form known as or operation equals. This exception is worth remembering. Great, so let's have the next slide. Okay, how to deal with single bits. Logical operators take their arguments as a whole, regardless of how many bits they contain. The operators are aware only of the value 0. When all the bits are reset, means false, not 0. When at least one bit is set, means true. The result of the operation is one of the values 0 or 1. This means that the value is snippet. Int I and j is not I. Not assign a value of 1 to the j variable if I is not 0, otherwise it will be 0. However, there are 4 operators that allow you to manipulate single bits of data. We call them bitwise operator. So they cover the operations we mentioned before, the logical context, and the one additional operator. This is XOR, or exclusively OR, and is noted as caret. Here are all of them. So the first one is ampersand, then one is bar, then is tilde, and one is caret. So the meaning for that is bitwise conjunction. Bar is bitwise disjunction, or NOR. It's okay. So this one is read as and. This is or. This one is bit negation. So it means negative or not. And this one is bitwise exclusive or. So that is caret. Okay, so let's make it easier. So the first one is and, or ampersand requires exactly 2. One is to provide 1 is the result. So the next one is bar requires at least 1 to provide 1 as the result. Next one is caret requires only 1 to provide 1 as a result. Only 1. And then this is a negation. The tilde is one of the arguments that requires 0 to provide 1 as a result. So, but take note, arguments are not operators. Operators must be integers or int, as well as long, short, and char. We must not use float here. Okay. So the difference in the operation of the logical and bit operators is important. The logical operators do not penetrate into the bit level of its argument. They are only interested in the final integer value. Bitwise operators are stricter. They deal with every bit separately. If we assume that the int variable occupies 32 bits, you can imagine the bitwise operation as a 32-fold evaluation of the logical operator for each pair of the bits of the argument. Obviously, this analogy is somewhat imperfect, as in the real world, all these 32 operations are performed at the same time. Right, so let's have the next slide. All right, guys, so let us discuss this table. So if 0 and 0, and this is end, so it will give us 0. So 0 and 1. So I'm going to use the conjunction and here. So it will result as 0 and 1, and 0 will be will be 0, and 1 and 1 will be 1. So let's have 0 and 0. 0 or 0 will prompt as 0. 0 or 1 will prompt as 1. 1 or 0 will prompt as 1. 1 or 0 will result as 1. So how about this one? The 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 uh, the the caret. So 0, 0, which is XOR, is equals to 0. 0 and 0. At 0 and 1, probably the answer will be 1. This represents as XOR, or XOR, exclusively OR. Then 0, then 1 and 0 will result as 1, and then 1 XOR 1 will be 0. So the difference between this one is the difference between OR and XOR are, if it is the same, the result will be 0, and if it is if the value will be different, then the uh, result will be 1 or 2. So let's have arg and negative arg. So arc is just like true or false. So if it is true, uh, if it is one, if it is zero, then it will become negative. So the 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 negative of zero. I mean, this is the negation. So negation means the if you are going to make it opposite. Okay, so negation is making the value opposite. So the opposite of zero is one, and the one is zero. So for guys, and now we um in this course, in this session, we have talked about we have finished the module 2 and have started module 3. And now in the next session, it will be on Monday at 9 a.m. And then we will finish module 3 and hoping that we will answer the module 3 quiz and module 3 test. And this concludes the session, this second session of the Diverse Node Mobility Front-End Development Program. Thank you very much, guys, and see you on the next session. Have a good day.